why would I want to use event sourcing in the first place? Um, that's a good question. So event sourcing, right? What's the point? And I would say I spent 20 years or something in the industry building applications, starting with like early PHP where everything was server pages, and at the top of the application or at the top of each page you would have include mysql.php whatever, and then you do some calculations based on that page, and at the bottom you spit out an HTML output, right? And this evolved over time. Eventually we started using things like active record, right? So the predominant paradigm in software development now is you have these objects that represent data models, database records directly one to one. So if you think like in PHP world and Laravel, you have active record, and it's implemented with Eloquent as Eloquent, right? And the idea being you can modify a property on Eloquent and you're directly modifying that column. You call save on the Eloquent object and it directly saves in the database. And then these data models are manipulated to implement use cases. So the pattern is a transaction script, which like says, okay, the use case of finalizing an order or sending an invoice or something is a sequence of commands that directly modify this ORM object and then save it into the database and get everything to the state it needs to be in. And this is a read case, but then it's also coupled to the write cases, which are like or I mean read cases, which are like, hey, I want to see all the orders that are finalized, or I want to be able to know where to send an email, and so I read this model, right? And so I realized at some point in time that the more that I wrote software like this, the larger the application became, the more coupled the various pieces became. And so I identified the problem that there's a real coupling problem between use cases. So I started segregating my use cases, still using Active Record, segregating the use cases, and I had a lot of positive outcomes. But this required me to start leveraging domain events, because domain events are like this highly effective decoupling pattern to separate these use cases from one another. So in the process of starting to use domain events, some like 10 years ago or something like this, we started becoming more and more aware of what was happening like in the DDD community, etc. And we found this idea of event sourcing. And it turns out that one of the things I have been missing from software development was having the code match the ideas that I was trying to implement. So there's a very high noise to signal ratio that I'm dealing with here on a day-to-day basis. The programmers learn about how the domains system should work, and then they map it in their head to a bunch of state changes, a bunch of database field changes, and then they just write the code that changes the database one by one. It's essentially like your entire business is running with a spreadsheet, and instead of a person modifying the spreadsheet, you're writing the code that modifies the spreadsheet, right? Uh, and so I eventually started realizing that what I would really like, something that would be really convenient for me, is to be able to listen to the idea of the business, like what are we trying to solve, and then to map out a flow chart, something that represents that process directly the way it's coming out of their mouths, and then to be able to map that directly to code. So when I found event sourcing, I was like, okay, this gives me this capability of having the code look just like the actual use case. It's like the most pure domain modeling, behavioral modeling approach. So there's a lot of advantages for this, right? For one, messaging is just logically convenient. Like the entire system becomes if this, then that. Like when this happens, then start this next thing. And that's just how the whole system functions. But because these are messages, events that, and these messages hit some kind of message bus, queue, whatever, then they're decoupled from one another. And so that it's like all these things that I've been wanting over long periods of time of just building these applications that increasingly become calcified to the point where they can't be changed. So like I went through this journey of like learning how to decouple all of these use cases from one another, and to write the code such that it looks like the domain logic with domain modeling. This is what I learned being a part of the DDD community, right? It was like a really transformative thing for me. And then getting into uh, event sourcing, like kind of was the icing on the cake. Okay, so now I can see that everything is based on these events. I can see, what happened. Like somebody's like, well, how do we end up in this state? And this happens to me all the time. I go to the event store or whatever, and I look at a stream, and I can say this happened and this happened. It's very clear, and it's very convenient. But there's like event sourcing in the pure sense, that is building the state of a model with events, and events are just the state of the model. And then there's all of the patterns that surround it that allow the functioning application to come together and function, right? Like we always talk about CQRS. It's not explicitly necessary theoretically, but you need to generally deal with it like in a real world situation, because you're not rebuilding your state all the time in order to be able to read every model. As a matter of fact, if we embrace CQRS, what we end up with is a write model that is completely segregated from the read model. But that's not directly event sourcing, right? That's something that just goes hand in hand with it when it comes to the practical concepts uh, of building an application. So I think that modeling the code is more straightforward, more simple. You end up with fewer types of code, right? So what we have in my production systems is a handful of design patterns that can be used to make everything, because ultimately the logic of these systems comes down to when this thing happens, we want to do this thing, and then the outcome is this. Mic volume is kind of low. Okay. Let's see if I can improve that. So if I talk at this volume, is it clear? Just to clarify, like if anyone would like to come on and chat with me voice, then you're very welcome to come in. You're also welcome to just post any kind of conversation topics to the chat. So like I said, this is completely experimental, never done this before. Um, and I just want to see if there is a interest there, if there's an interest to do this kind of thing. So to kind of clarify a little bit though, like my experience is I have almost 10 years of production experience with event source business systems. One was in a business I created, and another one is in a payment processing company. Uh, I have given workshops and trainings on these topics. I don't know everything. I haven't experienced it or brushed against everything, but I have been around a little bit, so I may be able to answer some questions that maybe if you haven't uh, dealt with event sourcing in the real world, or maybe if you're just curious, or even if you're kind of running into a problem, then maybe there's some value here. So feel free to chat with me about this. I would love to hear what you have to say. Also, I would say that if worse comes to worse, I could come up with topics like snapshotting, and why I feel like snapshotting is an anti-pattern. This is kind of a popular topic um, that comes up frequently, right? Because people, they see these event sourced aggregates as like an analogous to like an ORM entity, like, right? So you might have a customer in your application, like you have some kind of ORM that maps the customer's table to the customer object, and then you think, okay, I need a customer aggregate, but that is misapplying the concept of an aggregate. That's not what an aggregate is fundamentally, and there are consequences to doing it that way that will cause you a lot of pain over time. This is my assertion. I'm open for anyone to disagree, to have a conversation about that, but we'll happy to talk about that at any time. So also, like I said before, having to sit here and just pick my nose on stream. So if anybody, if you don't want to chat, then there's always that to look forward to. So I'm gonna, I guess, talk a little bit about event sourcing as the core idea, and then if anyone wants to come in and discuss anything, join the call, audio only with video, or talk in chat. That's also fine. Um, but there are some fundamental differences between event sourcing and writing a system that uses like what we call structural models. So I would first start by discriminating between structural and behavioral models, right? So when you think of normal development, you think of, okay, I'm a software developer, I'm super good at imagining database tables. That is like the primary skill for most software developers. You say, we need an order system that can add order lines and that will calculate taxes and progresses through these states. And you think, okay, I need an orders table, I need an order lines table. You start thinking of the third normal form and how you can structure all of this. You build a data model first. Then you map that data model one-to-one to ORM objects, objects that are simply there to represent those data tables. And then you have code that manipulates those objects from the outside generally in order to implement the use cases. A behavioral model is different because it's really you're trying to model the relationship between things. So if you say I have an order active record object, and maybe in your controller, or if it's a little bit more sophisticated in some kind of service object, you start by saying create a new order, set these properties on that order, save it at the end. Uh, that is that's a transaction script. It's very much about directly manipulating the state in the database, and that's what you're modeling. You're modeling database table mutations. But in a behavioral model, you're saying, well, I have certain concepts, and how these concepts interact, that's the thing that I'm focused on. So instead of having an order object and then attaching order lines to it and using relationships and stuff like this with the ORM, you have essentially this concept of an order, and now this order has a method on it called place, or this concept has a method on it called like add line or something like this. And in these concepts, in these methods, you have the ability to guard invariance and whatnot. So this is like a step up from that manipulate the database from the outside perspective that like we traditionally see. You can take this further by making it reactive, by focusing on like what's happening here. Oh, I have the intent of placing an order. Then you go and on this order concept, you call place and you get an event out and you store and dispatch this event. This isn't event sourcing yet, but this is the idea that this thing happened that's like behaviorally driven. It's about the business process. It's not about dispatching events or doing things that say, hey, this model was updated, order created. Like update, create, these kind of CRUD concepts. I think that these things don't scale well in complexity and aren't very useful overall. Like it just the penalty of utilizing these concepts is that you're having to mentally map whatever needs to happen in the business to this system, which is now a second domain, right? Like it's like the second highly complex thing that you have to map between and implement. So you're no longer implementing just these domain behaviors. You have this entire engine that is disconnected from these behaviors, and there's a cost to that. So uh, as like ideally what we want to accomplish from behavioral modeling, from domain modeling, is that if we have a small change in the business's ideas, we want a small change in the software. Now this is like the holy grail, right? It's about change management, really, because this software, like 10 developers on it, 100 developers on your monolith, like there's a lot of changes that are happening here. And as time goes by and as features are added, uh, when the changes to the system aren't like proportionally matched to the changes in the needs, there are like fundamental problems. The cost of implementing features or modifying features just goes up and up and up. And what happens is, like, this is my personal anecdotal experience, is what happens is the engineers are like, oh, why won't management give us time to refactor, or why can't we do a rewrite? We know so much more now, right? Why can't we do a rewrite? So then we get the budget eventually, because every one of the businesses is sick of their software developers. Why does this take so long? Why can't we ever deliver quick enough? And why do we have to change our business strategy to account for the slowness of this process? And so we get the budget for a rewrite, and then we go do the rewrite, and we build the damn system, the exact same patterns, the exact approaches, with the same coupling paradigms. We just changed the data models around it, like the workflow, the parts, the pieces that go together don't change. So why do we expect a different outcome, right? Now I realize I'm rambling a lot about my complaints with like using the data-driven approach, using the structural modeling approach. I want to again ask if maybe chat has any specifically event source related topics that you might want to discuss uh, before moving on. So like a little bit of my personal experience, I was running some conferences, Domain Driven Design Europe, Laracon EU, and also some other like Laravel related business stuff. And there's only two people doing all of the work, so I automated a lot of the work, that integrations between systems. And I decided that I was going to event source the entire thing, like every single aspect of it, to find out where the cracks were. And I decided that I'm also going to avoid aggregates for as long as absolutely possible, right? So this was a really useful and helpful experience for me, because I got to see, okay, what things don't work well with event sourcing. Things like, maybe for me in my context, things like authentication doesn't isn't interesting when it comes to model event sourcing those models. But having the event store, having the state of my system being represented in this event store was so amazingly convenient, because what happened is I took all, like, it feels like the architecture goes from this bespoke thing where you have just database migration after database migration after database migration, a very specific implementation for there's coupled to your reads and your writes. And it turned everything into just messages. So I write a tool to deal with messaging, and I could just reuse parts of that tool for other tools. Like it all turned into like one conceptual simple thing. Let me try to. And so the writing the tooling and working with these messages ended up being like a simple process. So all I had to do is implement good tools built around messaging, and I could continue reusing parts of those tools across the rest of the architecture. And the whole architecture became about reliable messaging, and utilizing these messages. So we have a question here from Alex. Like, okay, I've not used event sourcing, but been on the edge for a while. Let's think about projections. If I want to add more data based on a new feature request, I have to rerun all the events to build this projection, right? How does this work? So this is one of the beautiful things. Like, so the projection side of event sourcing, right? This is really, it's not about sourcing the right models. It's about sourcing the read side, right? So this is CQRS. This is done for practical reasons. You don't want to go through the entire event stream and read every single object to create an in-memory uh, display or a data model for the specific read case you're thinking. So let's say we have a read case where we want to be able to list all orders or list all active orders or list orders and see their status or something like this. The way we do it is we consume one message at a time and interpret it into whatever the read model is. The simplest example that's most familiar is just we have a relational database table called orders. It's denormalized as much as possible, right? You might still need references and have multiple tables in a single projection that you join together, whatever. But generally speaking, it's we have the advantage of being able to denormalize this data so that we consume it for reads. It's very simple to do, and it's very performant. It's built based on performance. And so if I have this table that's like I call order listing, for example, and it's keeping itself constantly up to date, we have the option of doing a variety of things to rebuild that projection, right? So for example, we can just copy and paste that projection or project it into a second database table, right? From a second queue. And we can cursor over the event store and read the events into the projection as a separate instance, and then flip a switch once it's completely up to date, saying, we're going to read from this one now, right? Another approach is so at its core, the projections are message consumers, and they need to be able to handle as message consumers. They are reading off of a queue. So if you think about it, like let's say we're just thinking about the most simple possible queue. Um, we can have multiple workers reading off that queue to project faster. And so what every message consumer that's reading from a queue really needs is like one, it needs to be idempotent. So when you reprocess a message, you have the same outcome. So it's not like if you process the same message 3 times, it's not making your state inconsistent. And two, we have to be able to handle messages out of order. This is just a fundamental part of scaling on a queue. So if we have 5 workers reading from the queue and they all read one job at a time, there's no reason to believe that one of those workers, the one that was reading the queue element that was injected first, is going to finish first, is going to process the state faster, right? So these will essentially be able to process out of order. So one way of doing this is to say, when I see an order was placed event, insert the record if it doesn't exist, right? Something like this. When I get an order was completed effort, insert the record if the last order update time is different from the current timestamp in the event. So what I mean by this is you can put logic in there. You can version your events and your event streams if you want to support this, so you don't replace state from older versions. There's a lot of ways to handle this, but what you can do with the projection sometimes, depending on how you write it, is just feed the events again into the projection. And if it's written in such a way that these events are going to project correctly, regardless of the order they came in, if you can make it so that it updates the state and corrects the state of the projection in the production projection. So I've seen this in production work. I've seen the switching mechanism work in production. But because we have segregated this use case, this one use case, this projection off from the rest of the model, from the right model, from the other read use cases, we have a lot more freedom about how we approach that. I think that freedom is actually really necessary. And I think that we should embrace it. We should take it to an extreme, like make it radical. Radically separate the use cases. We got to be practical too, but like separate the use cases so that when we say, oh, this listing, we want this different kind of approach. Well, what if other use cases are utilizing that listing? No problem. We can just copy the listing, make a second projection that's different, and then the read use cases can read from the correct projections then. So there's a lot of freedom here. Thanks for the question. If you have additional follow-ups, I'd be interested in hearing them. So in the example of, okay, no one thought to add date created to the projection, right? I've seen this kind of thing actually happen. Uh, is my suggestion create a new projection to include this, replay all the events to build this? So I think that you can theoretically, if you want to, uh, say something like this. If you're reading an order was placed event, if there is, for update this record, set the created at timestamp from this event data. Uh, if you can upsert it, right? Insert or update based on that data. You can do that kind of logic, right? So uh, you can also say, hey, you can have an if statement. You can query the data, and based on the state of it, you can say, I'm just going to inject or insert that timestamp. For something like created at, I probably wouldn't create a second projection and then deal with all that complexity, because it's really, you can just define a query that, generally speaking, it inserts the correct details, or if it's already there, you can update the missing data or something like this, right? I built a projection manager for my application, and I'm able to feed in events of different types based on parameters, right? So like, if this event type is order placed, I can just say, oh, I want to refeed in all of my order placed events into this projection, and it'll cursor through it, and update that data in the projection. It, I would say that you can build your projections in whatever way you want to. For example, I have seen active record like Eloquent, PHP, Laravel objects being used as the projection uh, interaction. I generally use SQL, straight SQL, with name parameter, like parameter binding. Uh, but you can use the active record objects. Like, you can say, give me the order object for this ID. Oh, well, there is an order with that ID. Then update its timestamp. No, Alex, thanks for the question. Really, really good question. I know projection management is kind of a big topic. There's a lot of like topics that we don't talk about a lot, right? Like, one of them is aggregate design. One of them is like the actual nuts and bolts of projection management. And a lot of the reason why some of these things are talked about less often is because you can approach these in your own way that leverages your own advantage, right? So if you're using PHP and like Laravel, you can do it one way. If you're using like Elixir, and like Ecto or Elixir, and you're writing into Elasticsearch or something, you do it a different way. Like, it's case by case basis. And so uh, you end up interacting with the problems of the system from kind of a different scope than you would necessarily in like a more traditional transaction script oriented data model solution. You end up thinking more about things like race conditions, item potency, because you're using events, and there's things that come with that. Like, how do I make sure that when I go from one, like, I use an event to trigger a lifecycle change, how do I make sure that event's not lost? Because if you do it a naive way and you just put it on a queue or something, like, what happens when that goes away? Like, how do you make these things durable? What happens when the message processor fails to process that message? Like, how do I make these things durable? So you end up going down a rabbit hole of embracing all of the uh, messaging aspects, right? And again, there are aspects that are event sourcing. You have the model that is built up of these events, and then there are more practical aspects that we put into our, like, information processing systems, um, that we just kind of need to make it work at some kind of not trivial scale. So this is like where, like, you see everybody, event sourcing is CQRS, is this, like, yeah, largely because like at scale you start to need these ways of dealing with practical problems. Hey, Codito. But I think it would be nice if we could like have more conversations about things like aggregate design. What makes a good aggregate? What makes a bad aggregate? Why? Why are snapshots problematic? And because I think that if you just start building a system and you're thinking, I have a member object in my normal way of writing software, I'm gonna have a member aggregate over here. It makes sense because you're looking, oh, I can put all the event generation in one spot for this kind of part of the system, this subcomponent of membership. But then because there's no bounding to this event stream, it can become arbitrarily large. And so you start, let's say over 5 years of time, you have built up 10,000 events, right? Like maybe that's okay to query and to put into your member every time you want to derive the state of that member. Maybe you'll choose to use a snapshot to fix that. But ultimately, the question is like, what immediate consistency concern could you possibly have that is bound over the entire life cycle of a member? Like, to me, this is like a fundamental misunderstanding of an aggregate. So it's event sourcing, right? Not aggregate sourcing. It's not about event streams. Event streams are a technical concern, right? It's really just these events come in and we process the events. But we have to sometimes say, in well, the user or the system is trying to implement this use case, and we need to make a decision. And we make a decision based off of previous state. So, based on previous events that have happened, we need to be able to make a decision now, and that will determine what the next event that's stored is. It'll either be like some kind of rejection event, or maybe we just halt the use case and say, no, use case is invalid. Maybe there's like, if we have an order and like, let's say the order is for 10 euros and we have 5 payments of 2 euros. For every payment, you're going to get an event out saying a payment was made or whatever. And then on the fifth payment, you get 2 events out. Payment was made and the order was finalized, or the payment was completed, or whatever makes sense for your model. Um, so we have to use the state of previous events in order to know that the order is completed. Otherwise, we don't know. Like we could replay every single event in the event store. Instead, we have this concept of an aggregate, which exists outside of event sourcing and event-driven architectures. And the idea is we need a boundary for consistency. And that means that if we are going to make a decision based on previous things that happened, then within this boundary, we have to have state that lets us understand what previous things happened so that we can make that decision. So the aggregate really just exists for accumulating that state and then making a decision. So it's like on like an event sourced aggregate in the way that I build these systems, there's no get method on them. You can't say, give me the number of order lines on an order. I don't do anything like that because I'm not coupling this aggregate to a read. This aggregate is for a write only, and it only exists for leveraging previous state for a decision now. And so what instead of having a member aggregate that is the same as like an active record object member that you would normally use, I might have a member registration aggregate, like some finite life cycle of cohesive interactions that leverage that previous state. And there's like a fundamental difference in how you think about entities in a system like this than how you think about it in like the traditional data model transaction script approach. So if you have a ORM object called order, it has an order ID and it has a bunch of data on the order, and maybe it has relationships or associations to other um, data. Like an order is connected to order lines, it's connected to a recipient or whatever is the model. You know that the order is an entity because it has an ID. And you know that the order lines are entities because they have IDs and they're modeled as entities. And an entity is this one-to-one relationship with the database. Well, let's say you have an event source model, which is an order, and then it's order placed, and there's an order ID in that event. That order ID is referring to the order entity. There happens to be an order aggregate in this case, but that shopper ID or something like this, or recipient ID, or uh, order line ID might be in one of these events that are related to an order, but there's no class called an order line in this context, right? So, like, just because, like, traditionally we have a class for an entity, and that's a direct data model access. But in these models, like, if you have an identifier that implies the existence of an entity, right? And you don't need a class to represent that entity. That entity can be represented across a wide variety of events that are all viewing and considering that entity from a different perspective. Now, Muhammad asks, how am I to know that the aggregate is doing its job as intended if I don't have anything to query its state? So the 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 state is known of the aggregate, right? Because the state in our context are events. So when we rebuild the aggregate from events, we tie this aggregate to an event stream, and the event stream is a technical solution to a technical problem, which is we don't want to run our entire event store into some kind of in-memory cache in order to derive the state of the system. So what we'll do is we will maximally reduce the scope of the aggregate, maximally reduce the scope of the event stream to the consistency boundary which we have modeled, and we will query that event stream out of the event store. Like, so let's say I have an order aggregate that is intended to have a finite life cycle to see an order from creation to completion, and I'm expecting 15 events or something like this over the course of that time, 20, 50, 100, whatever. Uh, every time I make an interaction with that order, the very first time I place the order generates events. And then in order to finalize that state change, I have to save those into a database somewhere. Like, just having events in memory that are generated within the aggregate isn't enough. So I say order, place, and I put in the parameters necessary. Then I store the order into a repository. And what it does is it pulls out all of those events that are new and stores them in the event store, right? Uh, so being able to know that this order is doing its job is actually trivially easy. You can just say, given that the following event stream exists in the event store, and then you just write out the events you want. When I send in this command in my system, or when I express this intention, right, to place an order, then I should see the following events generated new outside of the aggregate. So when I save it into the repository, the event store, for example, then I get to know, okay, in these situations, given an event stream where there's no events, there's no stream, then I want to place an order, then I should see order was placed event. That is a very simple test that really just takes up this much code, and it could not be more comprehensible. You don't have to set up a bunch of crazy mocks and whatnot to make this work. But if so to me, I don't directly test my aggregate. I test the service layer. So I write a command and I say, given that these events exist already in the store, when I send this command in, then these events appear in the store. The aggregate is downstream, and I'm not directly testing that because all of the use cases that I would be able to test, I can test using this given when them idiom, right? It's like the behavioral driven design idiom. Uh, and it's actually one of the big advantages of using a model like this. It's very easy to write, it's very easy to read, it's very easy to modify. When I look at tests that are about these highly coupled systems, these transactional scripts, and these data model manipulations, there is a ton of setup. Often there's mocks created which are directly binding implementation to this test code, uh, and we just don't need any of it. Now, let's see here, Codito. I know you had this conversation yesterday, Explain why snapshots are considered anti-patterns. Right. So there is some contention here, but I don't think you run an event source system for a long period of time with a lot of users or a lot of uses and don't come out having a distaste for the concept of a snapshot. So first, I'm going to define what a snapshot is. If I have a bank account is like the one of the examples to help people understand event sourcing, because you can see how each transaction in the bank account accumulates to being ultimately having a specific state. So you can model a bank account as both a list of transactions and a balance. And this is often done like that. So if a user has their bank account balance, they will say, I want to make a deposit. They will open a database transaction, write a transaction into the record, and then increase the balance using like pessimistic lock, or I mean optimistic locking or whatever, and then commit the transaction. And it all commits at the same time, so you don't end up with transactions in the database that are not represented in the balance, and vice versa. But people understand that like there's this like super old like way of thinking about accounting that says, all right, we are using double entry bookkeeping, we are having deriving the state of this thing from events, and now we are implementing that in our system. So let's think about this bank account example critically for a moment. You have a bank account, and from a naive perspective, this bank account has no bounding. This bank account lasts 10 years, 15 years. This bank account can last 3 months. I don't know, but it's not. There's no upper limit binding to this. So you can have any number of transactions in this bank account. And let's imagine we have deposit and withdrawal transactions only. So we do withdrawals, we do deposits, and we're able to internally, whenever we need to do that, we load up the bank account, we load the full event stream of all of the transactions, we feed them in to the aggregate to arrive at the balance. And now when we say I want to withdraw, it says, nope, not enough balance, and won't let you do it. Or maybe there is enough balance and it will let you do it, and that's fine, right? We changed the state of the system successfully. We've guarded our invariant, and the system is consistent. So over the course of 5 years, we end up with 10, 20,000, 30,000 transactions. I don't know, like it's not really about the length of time that a bank account is open. It's about the amount of transactions from a technical perspective, because this is theoretically completely valid. But what happens when you have a business that's processing a ton of 10-cent microtransactions, or I don't know what, like just as an example? It's not about the amount of time the bank account's open, it's about the sheer depth of the event stream. So if you have 50,000 events and you want to make any process against this bank account, you have to query those 50,000 events, you have to build the state into the system, and you're ending up with a very real performance impact. It's not only impacting like the user in the real world trying to make a state change, but it's impacting the load on the event store as well, right? So like it's largely undesirable to do this. So we come up with a pattern of snapshots. We say, okay, this bank account, it's fine. We every time we write events into it, or maybe every 5,000 events, we record the internal state, the balance, and we save that in another like immediately consistent relational way, right? And what we do is we just say, when we want to rebuild this bank account, we first find the most current snapshot, and then we bring in all of the events from that snapshot and accumulate the state on top of that. So the aggregate knows how to set its state according to the snapshot, but it also knows how to set its state according to all of the events, right? So now what we have is we have uh, coupled the internal state of this aggregate into all of the use cases, and no longer we're not no longer just building off of events. So what this means is, now if we want to change the aggregate such that like maybe we need new data from previous events, and so when we apply these events on load, we store new state, right? um, if now we have a different version of the snapshot, fundamentally, because we need the state of that aggregate in order to decide on what's happening next. Is this valid or not? We need that state. So If we modify the state of the aggregate, then the snapshot's no longer sufficient, probably, maybe, depending on like what's specifically happening concretely. The state's no longer sufficient uh, to rebuild the internal state because the state expectations have changed. When we have a snapshot, we are saying that we are going to be invalidating these snapshots in mass for all of these aggregates if an incompatible state change is made to the system, right? So this is just another type of coupling, another kind of limitation that is making us bend over backwards to deal with the kind of problems we don't want to deal with. We want to deal with like business related problems. We want to solve problems, deliver features. We don't want to just be shuffling bits around in this way. It's just more difficult. So you have to have like this giga brain to be able to think about and manage all of these situations, which is honestly, I don't even need this right now that nobody's on the stream, which is basically just it's just too much to deal with. So what happens when you change the version of like the snapshot and you have a like a heavily used system? Well, now either you start rebuilding all of those snapshots as part of some kind of automated process to warm up the snapshots because they're just a cache, right? It's a cache of the internal state of that aggregate. Or on the first usage, you realize this aggregate version is mismatched from the snapshot version, and you rebuild the entire aggregate. So like now you're like, how did you solve what problem did you solve exactly? You understand? Like you still have to build the state up, and you still have to reproject all of that state into a snapshot, and you're just keeping it so that you can't modify this aggregate. And you can say, oh, I haven't dealt with that. Well, that's okay. That's convenient. And I built like a system for years that didn't use a single aggregate, uh, just so I could like learn what the limitations would be like from like a really like on the ground level. Um, but in this bank account example, it's a real problem if you're going to change the logic at all. And so not only that, you're more likely to have to change that logic. You're more likely to have to change that state because you have this long running process, which means you're actually incorporating within the aggregate the expectations and the requirements and the rule validation for many things. You're coupling together more things into the aggregate. So as a result of the more use cases being coupled in, it has to change more often. We're not limiting or isolating the need for change, and as a result, it's all much more difficult. If we take this long running stream, this bank account concept, you could say, oh, well, bank accounts really work on like a fiscal month or whatever. Let's bring these aggregates down. But that is also a problem, right? Because it's not about the length of time that the bank account's running, it's about the depth of the stream. How many messages are in that stream? It's not about how long this bank account runs, right? So this bank account concept is like the a really beautiful way of explaining how state accumulates to create a sum or a result. But it's actually a really bad uh, demonstration of like event sourcing because once you apply it to um, like the practical real world situation, it falls apart. So Duca says, how would you handle the sheer volume of events then? We don't need necessarily this aggregate in this case, right? So I spoke with some of the engineers from a Scandinavian bank, Lunar, I don't know how it's pronounced, and they actually event sourced all of their stuff. And they said if there is one bit of advice they would give, it's do not make long running event streams. And so I hear beginners who are just like honeymooning on event sourcing, who are like drinking all the Kool-Aid. Oh, this is the greatest thing in the in ever, and you can just do everything like this. Um, I see them being proponents for snapshots, but then I see the people who are building these systems. They're always saying, "Do not make long-running systems." Hey, Josh, um, do not make long-running event streams. Right? So, like, take this with a grain of salt. If you're on the fence about it, let's work through examples. But if we have a ton of bank account events, what I would do is I would say there are multiple things we have to consider here, right? So for one, what's responsible for the balance, right? So I do know this is a complicated domain. Like this is I work at a payment processing company. There's a lot of complications here. You're not only thinking about how you need to solve for these immediate consistency concerns, but you're also thinking how to distribute responsibility across different groups, across maybe different services, different physical boundaries. There's a lot to balance in the real world design of a system, but you can easily imagine how something like a deposit would have its own life cycle, right? It's not just an entry into that a database. It is something that has its own step-by-step process. That is an interesting sounding aggregate to me. If you want to deal with like immediate balance consistency, I would actually say that any solution that is not a long running stream is desirable over snapshotting a stream. So that could mean that you have a dedicated system, whether off the shelf, probably, or built in house to deal with accounting, and that system has an immediate consistency requirement for providing a balance. And for example, if you want to make a withdrawal, you could have an aggregate for a bank account withdrawal. And one of the requirements for that is that you inject the interface necessary to interface with this ledger or financial bookkeeping system, and it's responsible for this. So I would not, I would just completely abandon a purely event driven model for this if it meant a long running event stream. Like, because the costs and the complication of dealing with this in this way is just not reasonable. But I think most of the time you can get away with modeling these processes that are tighter, that are smaller, that don't include every possible type of thing that could happen. Like, we got to get away from thinking of aggregates as this collection of places where events can be generated. An aggregate isn't just a boundary that holds all of the types of events of a specific subsection. It's an immediate consistency boundary. It exists to be able to solve race conditions. It exists to be able to solve for eventual consistency problems, right? So does some of that speak to your concerns? Do we want to talk about it further? Banks have statements, so an aggregate can be based on a monthly statement, which has an open balance. I would say a statement doesn't need to have any need to be immediately consistent in this context, right? So if you are receiving a statement in the mail, you're not seeing an up-to-date statement anyway. If you look at your bank account on the website, you have no expectation for that to have every single bit of data up to real-time standards, right? Like you're okay if like you make a purchase and the bank account shows it 100 milliseconds later, right? Would it be possible to keep using aggregate but fake the event stream with a snapshot event? Um, Yeah, so it doesn't matter how you implement the snapshot as long as you're not querying against and applying all of the events in the stream. So I would have a snapshot as a separate subsystem. I don't use them, uh, but I would have a snapshot as a separate subsystem that's optimized for that use case so as not to couple it to the event stream. I don't want to store arbitrary snapshot events in my event store. I would prefer not to have to delete them. I don't know. I just, to me, it's something that's easily solvable by removing it from the event stream. So I would not want the negatives that come with that, to be honest. It could be doable. You could do it. You guys say, give me the most recent event of this type, and you have set up indexes on your event store that allows for that, and it's the snapshot event, and give me that and whatever. But since snapshots become invalidated, since I just don't see the pleasure in that. It doesn't strike me as being a really joyous and simple implementation. That's my impression, interpretation. I can like so when I talk with people, I can I can like always so far basically everything except for the bank account example. I can come up with an event source solution that doesn't have a long running stream, right? So honestly, the if I was a bank, I would not even consider uh, doing like a ledger or a balance with an endless stream of events, unless I was isolating it and doing uh, tackling that problem in a very isolated and specific way, treating it with the as a first class concern in the application architecture and the systems design. This is how I would think about that problem. So Codito, this is how I normally see this implemented. Snapshots as a separate subsystem that's optimized for that purpose. So I don't know if there's anybody here who has an event source model that with long running event stream that we want to talk about and see if we can figure out how it could be decomposed into smaller aggregates or something like that. I feel like going to a college campus and sitting down with a table that says snapshots are an anti-pattern changed my mind, and I could probably spend a lot of my time on that and not feel wasted at all. So Noxie asked, did your work in the payment industry change the way you view event sourcing? I would say working at the scale that I work at changed the way I view event sourcing, because there are like I worked on a system before that was processing a lot of events, right? Millions of events per quarter, which I thought was a lot. But having had a chance to work in like a payment service provider and to have an event sourced transaction processing system, I started making more realizations. Like an isolated system that's oriented towards a specific service that's offering, right? Not like a microservice, but something more meaningful. Like it's built as a boundary that's able to handle the consistency requirements of a certain subdomain of the domain as a whole. Uh, I've discovered that there's often like these life cycles that are short lived that matter, but they're short lived. So if I'm processing a transaction, there's a limit to how long it takes to process a transaction. It fails or succeeds uh, within a finite amount of time. And so one of the like axioms that I use to kind of build the system is I actually don't want to rely on the expectations of a complete data set. So I've gotten further and further into this idea of being able to just archive off old chunks of the event store. I think that if your system is like scoped in a particular way, you don't need often like this huge historical collection of all data. So I'm really into the idea of having uh, only the events around in the events where they're needed to do the work, and you're transmitting events to the other systems and whatever. You're able to put these events into cold storage or whatever. Um, and I found that this is really cool because it maintains a certain level of, you're not just growing your database forever. I really think that managing data is like a really beautiful uh, a way to make our systems easy to work with. What happens when you have a billion records in a database because you have an API that lets you query against all data, and you're using that same database to process work. That's like you. It's hard to work with. Imagine making a migration on that table. What do? You don't make a migration, or you do a risky, complex operation. Like it's just difficult. But maybe you don't need all that. Like maybe if you're going to be servicing customers from your API and you're able to query against historical data, you just create a read model that has all that historical data and let the consumer pull from that, but at the right, the system that's doing the work, why does it necessarily need all that historical data? If we're able to tighten down our event streams and make them like finite life cycle, we can operate without the expectations of complete historical data. And I think that the simplicity that comes out of that is a beautiful thing. The aggregates are simple, the models are simple, and one of the most difficult problems to solve here is how do you deal with schema versioning? So I complained about snapshots and how you are dealing with aggregate versioning and aggregate state versioning and how that's a big problem. But you also have events that change over time. Add, remove data. Uh, Semantics can change. One event could become many. Many events can become one. Right? There are ways in which the system needs to flex. And you have to be able to, like, if you have a long running process and there's 5 different versions of a member was registered event, like maybe that's a stupid example, but just like think about it with me. You have to be able to project all of those different versions, and your aggregate has to be able to apply all of those different versions. But if you are just moving forward with these finite life cycle aggregates, you have a limited need to access any of those old versions. So because you have tightened down the scope to a temporal like scoping, uh, the difficulty in things like schema versioning get mitigated. You only have to deal with so many of these things at a time. And so these are things that you can start like making realizations about and implementing in the systems design to optimize and reduce complexity. And really these systems can be extremely simple and easy to comprehend. Now I'm going to look here and see, Josh says, I think most of my event streams only have maybe 50 to 100 events. Yeah, so I would say that's probably like completely trivial. Like you could increase that by 10 times and probably you don't see an impact. Um, so I wouldn't worry about event streams that are of that size. Codito says, practically speaking, what do you use as an event store? I have always used a relational database, um, either Postgres or like MySQL or whatever derivative is, whatever. Um, I think that an event store is a pretty simple thing, largely. Like, there's this Get event store that like Greg Young's company makes, and it does a lot of stuff. So that's like less trivially simple. But I believe, generally speaking, that if you build your own event sourcing tools, these tools are very tightly coupled to your environment, which lets you leverage the advantages or disadvantages with your environment. And also they're less generalized for all different people and businesses use cases. So they're more just simpler, just like you're not paying the price of an overly generated monolithic model. And there's limited needs you have from an event store, right? You write into it. It has like some kind of transactional bounding. Um, you read from it by streams. You can cursor over it in order to rebuild things. Like there's a finite amount of basically simple behavior. And whenever you look at any how these patterns interact, each pattern in the architectures that, like for example, I'm using, like I can't speak for all architectures. And again, event sourcing is like a very small subset of the things I'm talking about. The a lot of things I'm talking about are like patterns that come together with these event source models because they help me achieve the properties of a system that I want to have. But I have had no problem at this point with relational databases for an event store. I really have little reason to explore other options at this point. If we started seeing a problem or a failing, and we wanted to start optimizing this, I would be very happy to look at other approaches because I don't see how migrating would be that big of a deal. I think that largely you can say the event store is a database that can be sharded, partitioned. You can choose how you partition it. You can maintain reasonable performance and storage size expectations for this thing. Uh, and I see no limitations, for example, that Postgres couldn't handle. Houndy says, hi, Shawn. What are the important things to consider when deciding how much information that comes from an external context or system to include in events? For example, an order line item or a cart item that references a product. From what I can tell is that you can either store all of the data that would be necessary in the event or just store a product ID and fetch in the external system is needed, right? So this is a very practical question. And so there is a question of like, what kind of event do you use? Like, do you use like these like notification events, which are just the minimum amount of information to understand the state change? Like if an order is placed, you have an order identifier, you have who's placed, like not placed, finalized. Maybe you have the order identifier, like the person who clicked finalize is an identifier, and a timestamp. Maybe that's all you need. But then there's concepts like summary events, where you say, I'm dispatching an event now that this order is completed that has all of this information about the order, basically. And you can consume that from other systems. So there's trade-offs for all of these. And I guess the first thing I would start with is thinking about layers of semantic meaning. So it's fine to build the state of a model from events only. And it's fine to dispatch events for consumers, and it's fine to have projections read these events. It's fine to have all these things. But think about it. You don't dispatch to consumers in like a more traditional structurally modeled system your internal database state. Like you're not just saying query all the records that match this identifier and just turn them into JSON and send them over the wire. You're explicitly defining a contract. And then you transform that model to the contract, whether it's the same the contract is the same as your database tables because it just happens to be you design your database table that way. That's fine. But you're deciding that when I have multiple systems integrate, there is an expectation that this is a contract. There are backwards compatibility expectations. We're not breaking the connection between the systems just because we removed a field from the event or we changed the event name or something like this. There is an expectations to maintain that contract. So what I advise generally is that you have internal state of your model. Now, I'm not talking about just your aggregates. Your model being a larger thing than just the aggregates. Your model being your reads, your decision making, your message consumption reaction. These things that are internal to your boundary of your service. These can read your internal events based on whatever bounding or contextual bounding you have designed in your architecture. But I always recommend having separate events that represent your external contracts. And that way you can, instead of binding the external contract into your internal implementation, these can vary and change, evolve independently. So you still want to be able to modify your internal events and change your system freely. Like the system should be easy to change. If it's not, there's a problem. The contracts should not be coupled to the internal change of the system. Otherwise, the system's not easy to change because you have to always be considering the contract coupling. So it's nice to think about it this way to kind of get an idea that these events are your internal state. They are not just to be exposed everywhere because then you don't have change isolation. So when Houndy says, how do you decide what kind of information is in an event? How do you decide how big or how small an event is? These are very practical considerations, but what you can do is you can realize that context is king. The way that two different groups who have different incentives or different responsibilities view an event, view an occurrence in the real world, right, is going to differ. So if I have a model that is responsible for marching the order through successfully and consistently, that aggregate, it's like I want to get from an order being placed to an order being finalized without breaking my business rules, then you have this model. But if I want to say I want to be able to like process transactions, but I want to be able to reflect on various properties of those transactions, you can do things like communicate the event that is like, okay, the order was finalized. At the same time, you communicate an event that's like a summary event with more detail, right? You can react to an event, interpret it, and then trigger more events. Like there's a lot of approaches to doing this. You're not limited to a single perspective on an occurrence. You have the freedom to model many different perspectives of the same occurrence to satisfy for practical concerns or otherwise. So I think traditionally, like you think, how do I'm making this event. I want projections to be able to be meaningfully made. I want the aggregate to have all the data it needs to progress to the next stage, etc. So you model the data involved with that occurrence so that those requirements are fulfilled. And you just generally try not to omit anything useful. But then it's also possible to, when like an order is finalized, to query the state of a system or to identify what has happened in the past uh, to construct a perspective that exists now, if that makes sense. And you can create a summary event, you can create different kinds of events based on different models. And it's always possible also to integrate multiple event streams together. So traditionally, we think of an event stream as here's an order, here's an order, here's an order. These orders are completely parallel. They can't interact with one another. So you can think, oh, well, what happens when you need it? You need to say, I can't have three orders for a, I don't know, fiscal something or another period. That's a really dumb example. Let me think of another example. I want to process a charge on a payment, but I don't want to double process a charge. So I can have the idea of there is this ongoing process of processing a transaction, and these charges are life cycles that we're integrating with banks in order to accomplish. So we can say there's a charge, there's a charge, there's a charge. These completely parallel to each other. They don't intersect. But we can decide that there's a concept that does intersect them. And we can create an aggregate that is used as a parameter for another aggregate method. And then we're calling methods on both aggregates. And this is really hard to discuss if you haven't dealt with this before, but it's possible to say, I have these parallel processes to draw a line through them and then have an event stream that exists to perceive some subset of these events, like a charge is being made or a charge is being requested. It can perceive a subset of these events from a new perspective. And the new perspective is, oh, I'm beginning a charge. And that way, when next time we try to begin another charge, we say, has another charge begun in this process? And that event stream has that information. So it can guard it. So it's possible, if you just think about it geometrically, that an event stream is a line and that event streams that don't interact are parallel. You can decide that event streams can interact by creating a new line and drawing them through. I don't have a way to show you in a more visual way right now. I'm not prepared for that. Um, yeah, hopefully that wasn't just complete garbage. I would say also, I would just add, when you're building a system like this, you should build it with evolution in mind. Like don't get thinking that I don't want to change these events. If there are difficulties in changing your events and evolving them, then confront them. Make them easier to change. Like figure out how you're going to do schema versioning. Figure out how you're going to do these things. What do I tell my hairstylist? So I want to grow my hair like yours. Uh, don't take the length off. Yeah. Um, let's see. I was talking about something. Oh yeah, the system should be evolvable. If the system's not evolvable for some reason, there's a problem. At its core, we're trying to do two things in order to satisfy one thing, and the one thing is all of the all of the requirements that a software developer has is to support business strategy, which means to be able to react to opportunities or to or whatever, like to change the system, whether change is creating a new system, modifying a system, removing components from a system. All of our what we need to do is to be able to do this quickly and easily, right? And so we get this from building articulations in the system, units of isolation, such that when we modify a system internally, we modify the part that needs to be modified, the ramifications are limited to the rest of the system, to the parts that logically must also change, but not to parts that logically needn't also change. So an important part of building a system like this is embracing change of the model, embracing the fact that the aggregate can change. That's what snapshots are a problem. Embracing the fact that events can change. That's why long running data sets present an additional challenge. Like, so let's just make applications that are easy to change, right? And to do that, let's like make practical trade-off decisions around that. And to me, being able to modify events and to expect that the system is still operating without like a huge historical baggage is pretty critical. Do I ever go back to change what is stored in an event, like if an event is changed? Right. This is the immutable event store question. Now, the traditional responses are something like, yeah, you can create a different event store by reading in all the databases and creating a transformer function that modifies the events and projects into a new event store. I don't have experience doing that. I don't think it's like intuitive or necessarily makes sense to me. This problem in some way is just a modeling problem to me. So there is a concept of corrective actions or corrective behaviors. You can say, oh, I want to correct this thing that happened, right? And you can create an event that does that correction, and you can build correction into your model. There's also ideas like you're often in software development serving multiple masters. So ideally, you want to be the authority of a thing, and some other thing is the authority of a thing, but you have to make judgments based off of the external state as you see it now. And then you might find out later that the external state's different. So one way you could think about it is if I'm trying to process a financial transaction, after a certain amount of time of this thing not being processed, I might expire it. But what happens when the problem was some queue somewhere was busted and I wasn't getting updates, and so I expired this thing and told everything that this expired, and all these other systems are reacting to that, and the semantics are that it's an end of life cycle case. Well, I need to like acknowledge the fact that I'm serving multiple masters. I have a perspective that I am the authority of, and the external service has a perspective it's authoritative of. And maybe I'm going to make a judgment call that's wrong. Like maybe I have to model this into the system and create a way to be able to express this and build the semantics of the protocol between services such that they will be able to support this, right? This is like a not an unusual situation. And it's really not about event sourcing, right? It's about just systems design. Um, the question was, though, about changing the events that were stored. Um, I have done it. Here's the problem. What are you going to do? Like reproject every projection? Or like how do you know the system as a whole is now consistent? So theoretically, you're not infrequently making decisions based on eventually consistent data, also, right? You're not only making decisions based on immediately consistent information. Often, you don't even need the information to be immediately consistent. If the information is not there, you just knack the message and like wait for it to come in again, or whatever. There's different approaches to this depending on your required level of durability. But uh, yeah, I would say handle this in a case by case basis. But largely speaking, uh, if you need to make a correction, it's probably better to represent that in the model uh, than it is to modify the event, because otherwise you have to reproject that event. And if you communicate, what are you going to do? Like dispatch that event again to other systems that have decided that they're no longer receiving messages on for this event because the life cycle's closed or whatever. There's just a lot of complications depending on if this is a public contract or if it's internal only or whatever. I don't know. You decide what the parameters are, what the expectations are for your system. So if I say backwards compatibility, what it means to me is I can change, I can add keys and values to a message, and it's still backwards compatible. What I'm telling all the consumers is you need to be able to support this. This is your expectation, and I can make that expectation. But if somebody has the expectation that the schema is going to be exact and we're validating the schema exactly according to a schema registry, and you add a field, you could just break their system, right? And you have to go through a pretty rigid kind of process to support versioning on a larger scale in your contract. And contract design is an important part of systems design, and it's not about event sourcing, but because we're using events and messaging and it has all these analogs, it comes up. And I don't know. I don't directly modify my event store, but I have these short-lived things that are over, and they're over whether or not I like it. So by the time I can react to go and modifying an event, the thing's already done, and like fixes have to be done, but fixes usually don't have to be done in my system. Fixes have to be done somewhere else. Some sucker who believed me, right? They believed me. They did a thing. So if I'm doing financial transactions, I can say, we transferred this money or we didn't transfer this money. And then we find the money came over anyway. I told them that we didn't transfer the money, but they found it anyway because reconciliation is an important part of a financial system, right? So we determine, do all the numbers add up? And that is a very important part of the system. That's a separate system than the system that is making the charge right now. And my system, in a way, doesn't have to correct. The corrections happen somewhere else. And that's like a normal, very normal. So I only need to do my job. Does anybody want to come and do a voice chat, or like I'm very happy to continue talking to the chat, the text chat. That's also fine. Just let me know. I can just send you a meet invite and we can chat face to face. So a more concrete example on an internal system only. If we have an order create event that has an order number property, but later it gets renamed to customer number. Yeah, so you can have a schema in your event store, and then you can have it being represented in different ways. So often we instantiate our events into objects or structures, data structures or whatever, and we can instantiate them with logic. Like, so what is a common strategy for dealing with schema changes is uh, upcasting. The idea is you can take the previous version and then cast it to the new version. So you might have two different events and you load it up, and whenever you come up with a v2 of an event of order created v2, I wouldn't use order created as order replaced. We'll use the business logic, right? So then the business language rather, and then you load up a version that's older. You might have an upcasting system that just says, oh, I see that we have an order number, but we know how to translate that to a customer number or whatever. You can upcast the events to the new version, right? And that really is about the representation in the application. So there's a code representation, there's a storage representation, right? There is the dispatched over the queue representation, right? So if you use like Google Pub Sub, or you could use something like Cloud Events specification for the format of your message. These are different representations, and they should be implemented within boundaries that represent the fact these are different representations so that you can change one without having to change them all. Rick, I got 30 minutes on stream today. So my goal is to try to have a regular scheduled session where people can talk about event sourcing and we can chat, right? Like I said, I've been doing this for a while. I've been around, but I don't know everything. I haven't done everything. And so maybe like I can learn from somebody else, or maybe I can share my experiences. And I would love to have more like one-on-one conversations with people, like in a kind of public space, because I think there's a lot of topics that are just largely avoided because they're not comfortable talking points, or they're too based on individual circumstances or something like this to really have an effective conversation sometimes. And I would like to approach some of those conversations in public more. I think this would help me grow as a software engineer, and maybe help people not drink as much Kool-Aid when it comes to the event sourcing concept, because I know for a fact when you get into it, it's the best thing ever. And to me, like it's like my de facto way of modeling now. But I'm past, I feel like, this honeymoon step where everything it just solves everything, and whatever. I'm applying it more with more experience, I guess. And I would love to have more conversations with people about this, whether somebody is like no experience at all, or whether they have more experience than me, whatever. That sounds like a great opportunity for me and other people theoretically. So, have you ever had a situation where somebody modified it directly in a relational database? Right. I have not had that experience because, frankly, uh, I'm not allowed to modify production data. I have to, the code has to be the only thing that modifies the data, and that code goes through like a multiple I policy and regulation concerns and stuff like this. Even if I was in like a more casual space where it's the Wild West and you can directly modify data in production, well, I mean, just don't do it. Is my like, or decide if you want to do it. Like, it's not my job to tell other people how to manage their event store. But if you're working with me, let's just have like a little bit of trust that we're not modifying the event store. Or if we are, we're doing it with full understanding of the ramifications. That's okay too. I don't care. I don't stand on principle. Cool, Rick. Yeah, like I'm thinking like maybe later in the day is better, because then like the North America, South America type side can join in also. Because right now it's a little bit early for them. They have a really big advantage of doing like live events, don't they? Because like they get like Europe and so many areas all at their reasonable time, and the rest of us have to go live in the evening when we're already tired. So yeah, where are we at? If it's your de facto way of modeling, what parameters make you decide not to event source the system? What if I don't care? Like I like event sourcing because it's easy to use, and it's easy to represent a state machine with it. But what if I don't care about somebody logging in? Like how that progressed through some, like how does that make sense, right? Um, I will just make an interface that lets me integrate with some subsystem that does authentication for me, and then have some concretion back there that does all the work, and then I only ever integrate with the interface from then on. That's like how I write. So either I care about the state changes or I don't. And if I don't care about state changes, what's the point of modeling the state changes? If I'm going to have events anyway with all the state changes, because I believe that events or messaging in general as a decoupling pattern is like the best possible way to have different features that are not directly coupled, that can evolve independently, but then they couple on a contract between the contexts. Well, I'm going to have events anyway. Uh, Maybe like event sourcing some model will just tie into all of that. Maybe it's just like super synergetic. I would say that any ETL system is a bad fit for event sourcing. That makes sense to me, right? It's not just about data transformations. It's about state changes, and it's about processes. It's about behavior. That's how I see it anyway. Um, really, you could make an argument of all kinds of like edge casey type stuff. You could say we're sourcing game state from events when we are doing internet gameplay. I don't agree, because generally speaking, they're just firing UDP at each other. And yeah, they have events, but these events have updated state. They're not relative state. An event source model has like largely relative state. So it has meaningful state changes from pre-existing states. Yeah, modeling, like if you're doing data modeling alone and not modeling behavior, maybe it doesn't make as much sense. I want to react to a specific business concept. I don't want to react to order was updated and then get the order was updated event, of which there are a tremendous number, and then look at all the properties and say, based on the previous state of this order and the current state of this order, this is the thing happened, and now I want to trigger this next state. I don't want to ever have to deal with that kind of state introspection chain checking. When a state change happens on order, I want a domain event that describes that state change in a way that I need to react to. Events are about reaction. Like there's a reason it's called a reactive architectures. If I'm not reacting to a thing happening, then what am I doing? Like this doesn't make sense anymore. So yeah, like for me, if I'm modeling, I pull up a diagram, or like do it like make a flow chart and say, we have this intent that goes into the system, and these are the constraints that are checked, and then this is the outcome. If you want to finalize an order, in order to do that, you have to meet these criteria, and then the outcome is order is finalized. And then there's another stage, like when the order is finalized, we want to send um, a payment request email or something. So then I say, when this happens, then I want to create this behavior. And then I can model an entire system with like 5 different types of pieces, right? Commands, which are the intent, constraints and variants, business rules, guards, all one thing. Events, outcomes that mean that the decision was made. It's a communication. The decision was made one way or another. An interpretation was made by the system, right? Things like a message consumer or a process manager or a policy, depending on what you call them. These are all one thing. Like they listen and react to the message and then do a new thing, right? There's like a handful of different patterns that you can use to model in a flowchart diagram, like any system, basically that is behavioral. And then you can just say, okay, I understand how all these parts work, and you can build an architecture that directly represents these components in the software in the same way. Now we have commands that represent intents, and those are just data structures that have a name, like finalize order, with all the necessary data in order to finalize order. This is the order ID. This is the person who's clicking the finalize button. This is the time at which I'm attempting to finalize the order. This goes into the system. The system makes decisions, and then if there's a successful outcome, out comes the order was finalized event. And now I have a command that's a structure, a data structure. Now I have an event that's a data structure. And then I have logic in the middle that is making the decision, right? And I can map one to one this diagram to the code. So if I design the diagram, I could just color different parts. Say this, you're doing this part. I will color these parts. You're doing this part, and we can break up the work and just design the pieces one to one, right? This is the power of the system. I don't have to go model, like, how do I map the idea of orderize or finalizing an order to a relational table, and also take into consideration read use cases and other stuff like this. I don't have to make that map in my head. I just model the actual thing the way I think about it, the way that my business thinks about it. They have an understanding of how the business works, and now the engineers have to come in and create a completely separate engine that works completely differently, but ultimately gives me the behavior I want. And then when I ask them to do a simple change, they say, well, it's not so simple, 3 weeks. And like, dude, that's like a tiny change. Well, like we can do better. Like, and it doesn't, you don't have to be an event sourcing. You don't have to implement event sourcing to get these outcomes, but this is like to me like the epitome of behavioral modeling in some ways. Again, I don't think I'm drinking the Kool-Aid. I think I just have really positive experiences with this in certain environments, and not as positive experiences in other environments. And this I think I got kind of dialed into where I'm comfortable with this approach. But I tell you, like for me, when I'm making something, if it's at home, if it's at work, my default expectation is it's going to be built based on events, because I want to model this. When this happens, this is the outcome relationship as the core of my software architecture. Because again, I want a small business change to equal a small code change. A large business change can equal a large code change. I don't care. That was always going to be the case reasonably. But getting those small changes proportionally small, that is an art. That is like that is the whole purpose of software engineering, of design. Um, Otherwise, like anyone can make a thing work, right? A first year programmer in the industry can make basically anything work. You go through these phases of, okay, I can get more or less anything to work, and then you may be like, don't improve for a long time because you already have everything you need to succeed. And then you go in and you start asking, well, what parts are not working well and how would I improve those? Then you have to change again. uh and I think that really, like, we need to make these decisions based on, in our real world circumstances, in a very practical context, can we isolate our change? Can we continue to add features and behaviors without bogging down the entire development process? Because I am super tired of building and building and building a bunch of active record data models or mapped data models that are modified with transaction scripts and expecting this to scale. You get to a point where it stops working. The maintenance of the system is terrible. And there are ways to isolate, of course, these kind of models as well. But I'm not like very. I'm just ranting at this point because I'm just frustrated with software and the state of software. So if you are loading up a form to edit an existing model, will you load the data from a read model, or will load the data from an aggregate to populate the form? Yeah. So from a read model, it's eventually consistent. There are so how long does it take to update a read model, right? You can build the system so that it updates the read model in double-digit milliseconds, maybe less depending on your setup, right? Um, Now I'm trying not to go too far down a specific rabbit hole here. It's 100% possible to have immediately consistent read models. I don't want to talk about that. Rather, I would say that there are ways to understand at write time if you are applying a change to a differently versioned state. Think of it as optimistic locking. So your state can be represented in a form. You could submit the state, and then when you try to make a change, um, you can say, "Oh, this was version 8. I'm trying to apply the change to version 10." You can do something about it. But this is very much not like a procedural state change. This is like I'm editing data. So like in some ways you can say, how much do I care if I update my profile description? Do I even need to go into an aggregate? What business rules are necessary to update my profile text on twitch.tv? Maybe you don't need any aggregate in this context, right? Like just dispatch the event, and whatever picks it up and updates the text when it gets around to it. Um, so it's okay that you don't use the immediate consistency boundary. That's preferred, probably, in my judgment. if you don't have a need for immediate consistency. But there are ways to deal with uh, versioning state and becoming aware of the state being versioned. But I would say these read models and your architecture can be built so that it reliably updates and projects the information very, very quickly, reducing the impact on the user interface. And there are generalized patterns. Generalized is important because you can just create a middleware, or you can create like reusable components that will help you to manage this kind of state mismatch. Yes. So that I feel, Josh, I feel very strongly on this topic. I feel very strongly that we do not want to have just this convenience of this boundary with a bunch of data in it. Uh, yes, I understand that it's convenient, but what it also does is it it's not radical enough for my taste for making the system evolvable without work. So I don't know if you read the book The Goal or if you're familiar with the theory of constraints, but I'm always thinking about what does it take to get this next job done, and where are the constraints, where are the issues that come. Uh, and what I see when I look at software development teams, everywhere I look, like this is not a judgment on any group. What I see is always this idea that there's so much unplanned work. It's like how can we believe that we can project our business goals and tie in engineering to those goals if the whole time we're dealing with these like undesirable kind of like yak shaving tasks that just have to keep being done? Shouldn't we like maximally reduce those? And to me, having this long running event stream is not doing that. It's inviting unplanned work. And I don't want to do that. I want to remove that from the equation as much as possible so that I can do the things that need to be done without spending a bunch of my effort, my focus, and the business's time to try to deal with the fact that now my aggregate state is invalidated and I have to decide how to deal with that, or I have to be able to support 10 different versions of an event over the course of 5 years, or whatever. I want to create parameters so the system has properties that avoid these problems, at least mitigate them and limit them. And that I think is where you get if you have production experience. So if you're in the industry for like if you're in production for like 5 years, you probably already have some forms of this manifest in your workflows, in the way you implement these systems, right? And this is one of the benefits of, I think, also implementing your own tooling. Now, I'm not going to say it's the right thing for everybody. You need to understand a lot to implement your own tooling if you want to like a maximally mature system. But if you want a system that's just suitable for what you have now, I don't think it really is that big of a deal. And I think that if you're going to use event sourcing in production, then my advice would be to use it out of production with your own build tools. You don't have to have a database. You don't have to have any of that crap to build a model that's event sourced. You can just run it at runtime. You can have a single PHP file that has an aggregate events, projectors that project just into memory and then output a result. And so you can just build this in one file. It's 100 lines long, and now you are like starting to gleam into like the ether of what this thing is. But if you use a pre-made framework or something, it's going to mislead, and it's going to tell you things that are it comes with a baggage attached. And so like my advice would be like, build your own baggage. This is me reinventing the wheel, by the way. Like this is the complaint that people have, because for me, the systems are so much simpler, easier to modify, easier to understand, easy to expect, predict. If you're largely responsible for your own system, because the environment's changed so much. Like at work, maybe I'm using Kafka and all this other stuff, and I build a bunch of tooling around the capabilities of these systems. I'm not also building a bunch of tooling around RabbitMQ or PubSub or whatever. Like I can isolate my needs. And just, like imagine making an all-purpose event sourcing framework. Like Frank de Jonge, I think, did a great job because he has a system that accounts for all the important parts, but lets you implement things the way you need to if they change. Like that's just good software design, right? But I don't think they're all built like that. I don't think that. I think that you can use a prescriptive framework without trouble until you run into trouble. And then what that I don't know. I don't know why I'm rambling on this. It's just a feeling I have. See, we have about 10 minutes left on stream if we want to talk about anything else or I think if you get experience with event sourcing for a while, you can probably make your own framework in like a couple months reasonably. I don't think that you need to do that at work. I think you can use something off the shelf if you like, but just just realize that you're going to have to learn a lot about their model, which is not necessarily transferable or maybe what you want. It's okay though. Yeah, you can shard based on or partition shard, whatever, based on any parameters you want, right? Uh, you can shard based off of like ring, like some kind of ring approach. I use a single event table, but then I think that if you partition early, because you understand how you're going to want to partition, like if you have the concept, oh, I want to partition into different regions, or you want to like do something like this, then why not just partition early? It's not a lot of work. You can partition later too. The way I see it is, what does it take? You could one, all the work is in designing it. Like, how do you want to partition and why? That's where all the work is. After that, you can build your different data sets and then just read from the right data set. Like, there's no work there. It's all in making the right decision. So to me, largely, I just work with it until it becomes a problem, or if you know what you want to do, then do it sooner rather than later. So now the rest of the system's built on those expectations as well. And because if you go to partition it for some reason you have other things that expect it not to be partitioned, then that's extra work that you have to deal with. Ect tone framework. No, there's a lot of frameworks I haven't looked into, but I imagine that this is going to get more and more popular, and there's going to be more and more tools, and probably a lot of them are really great. That's my opinion. Probably a lot of them are really great because it's a really cool thing. Everything becomes pipelines, everything becomes streams, and you just operate on streams. So why not have stream primitives? Why not have ways to deal with this that are just highly generalized and reusable? Um, when it comes to PHP, I basically use either something I wrote myself or event sauce exclusively, basically. Um, in Elixir, I'm writing my own because I want to solve my problems that I have with my system architecture in an idiomatic way for Elixir. So I'm doing that all by hand so that I can learn the things I need to learn for that space. Uh, but then I imagine that the engineers who are using these tools are also capable of coming up with really smart and good ways to do it. And so then after I kind of figure out how I would solve these problems, I'm going to go and look at what everybody else is doing and learn from that as well. So yeah, I think this is probably a good stopping point. I want to thank everyone for like showing up and participating. It was a huge experiment for me, not knowing what to expect. Just kind of I came up with this idea yesterday, so really cool that you could attend. And I want to like do a regularly scheduled stream where like we talk about event sourcing, but like then maybe later expand out into various other topics. I just love talking to people about software development and the philosophy of it and the application of these theoretical ideas into practical circumstances. So maybe let's uh, let's try like to have more conversations on these topics. Yes, and please, like let's get people participating in these conversations. I would love to have someone to chat with who could, um, you know, engage in that way. So I'm gonna go ahead and stop the stream. Thanks again for everybody showing up. I really appreciate it, and maybe let's try again next week. Like follow me on Twitter or something like that, or chat with me on Twitter, and I will